Good evening. Well, what the hell? Good evening, and welcome back to Vegas October 1 Sounds. Tonight, I'm going to continue on with the first 6 shots analysis. These are the first 6 shots that are heard that evening, and they are spread kind of far apart. All total, all 6 of them are completed within about 8 seconds. So some time ago, I started a project to find, locate, and categorize and characterize all the videos and all the shots within those videos that are related to these 6 shots. Because not every video captures all the information in as great a detail as would be preferred. And certainly some of the videos have shots or muzzle blasts which are not as audible as the others. In fact, some are missing a couple. I'm not going to try to explain all of that this evening, but what I'm going to do is introduce you to the state of the project, because it's not complete. But I'll show you what I know so far and how I know it. We're all familiar with Sonic Visualizer by now, the tool I use to go in and look into these files in great detail. But let's take a step forward and look at the results of some of that so that you can get a feel for the end result. Alright, so what I did was I took a Excel spreadsheet. I use OpenOffice, but so it's an ODS instead of an XLS. What I did was I took a look at and gathered up all the videos which I thought were usable material. And what I did was create an Excel spreadsheet. And let's take, for example, I like this one. This is kind of a zoomed out view. And what I've got is I first take the video, and for myself I visually identify it. That is, I take a picture from the video that would logically represent what it's about and where it's located. Because from that picture you can immediately recognize where you're at, roughly speaking. So for example, for bar 7 here, you can, right in the middle of this, you can see a loop of metal or plastic or something, and that was right there near the sound stage. And since it is right of center of this picture, then we know that our location is left of center with respect to the venue, or on the east side of the sound booth. Now sometimes how far away from the stage you are is a little deceiving, because you don't know the zoom factor on the that's being used at that moment in time or throughout the whole video. So you have to visually watch the video to get some idea of the zoom factor. And in fact, to locate where this video is at, you sometimes have to watch the video and apply several filters to find spots which you can use to triangulate the position of this. And I do that. Now this is a work in progress, so not everything is done everywhere for every video. In fact, I still have several videos I want to add to this whole project. Where I'm at generally is I've taken 12 videos, and I have characterized and done a first shot breakdown of which video contains which supersonic cracks for which shot, muzzle blast, reflections, and other significant stuff. The next step of this project was we see that here under Sonic Visualizer columns. But before we get too far into the weeds, what I do is I look at the video, I look for interesting things in the video that help me demark where it might be located, and then I go to Google Maps and I look for those things and reference it and try to come up with a reasonable position here. So in this case, I've located the video where the little white dot is, and I did it by making reference to those two big tall towers and the right edge, right as you're looking at it, right edge of the marquee sign in front of the Mandalay Bay. So somewhere in the video I was able to look at a few frames that showed those things, and I could get a rough idea of how to locate the video. Once I've done that, I start taking some notes. In this case, the notes on this video indicate that if I take the first few frames from this video and I increase the brightness, contrast, and a few other things, then I could see the twin poles even though it was dark, and I could see in that field, south of the venue, and I could see them about middle of the top roof of the stage, and so that gave me one point of reference. And then some other the same frames also showed a portion of the marquee sign, and also showed that large screen of the big screen on the stage blocking or obstructing by a building. So all those points gave me a good indication that this was near the western rear of the sound booth. And I also noted that round thing I just pointed out was part of the sound booth. So those are some notes. In this case, I have not done any audible analysis. That is, I have not listened to it carefully and determined which parts were which. But on this one, on bar 6, I noticed that F1 was audible, and it's a dark green, therefore it was quite audible. F2 was light green, which means it's barely audible or maybe not at all. F3 and F4, the sonic snaps were not, but the muzzles were for 6, 5, 4, and 2, not crazy loud, but loud enough to do that. And then I noticed on bar 6, overall quality is 4, blah, 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 blah. And over here, from the sonic visualizer side of the information on that particular video, I noticed that the supersonic crack for the first shot was weak, and nearly everything in that video or that audio was weak, and it was actually missing the muzzle blast retort for shot 3. And so I do that for all 12, and I do other things too. This one, which is a bar 7, and that's, I found so many videos that had the bar stool in them. I just started calling them bar 1, bar 2, bar 3 on up. The sonic visualizer review gave me, for this video, which is what did I say, bar 7, gave me interesting stuff. It said that you have, for the supersonic cracks, you have strong on the first one, strong on the second one, strong missing on the third, missing on the fourth, strong on the fifth, strong on the sixth. But it also had muzzle blast of weak for the first one, fairly good to strong for the second one, and strong for the remaining one. So in total on that line, I see that I have more muzzle blast recorded than I have supersonic cracks, and that is an indication both of the location and the path of the bullet and the location of the shooter. I also noticed in here that there were 3 hits recorded somewhere within the vicinity of that recording, in a close enough range that they could be recorded on the tape itself. And hits are basically, they appear in the sonic visualizer as rather large regions of intense sound at a low frequency. And I also noticed that there were no reflections. So many times, as example in this one, which is bar 8, you see that there's no hits, lots of reflections. In fact, the reflection for every single supersonic crack, not a very good one, but there were. That one I haven't done because there's no shots recorded on the video. And here in this case, bar 11, we have reflections strong for the first supersonic, weak for the 4th, a little bit greater than weak on the 5th and 6th. And up here for the hits, we have a very small sound recorded for near the bullet of the first shot, and something near the 4th muzzle blast, but I'm not clear on what it is, but I called it hits, so I'd go back and review it. And then up here on top, we see that for supersonic cracks that would be clearly audible, we have 1, 5, and 6. You might hear 3 and 4 with a lot of amplification and good earphones, but you're probably not going to hear supersonic crack 2. On the muzzle blast side of thing, you're definitely going to hear the 5th one, maybe the 4th, but certainly probably not the 3rd and 2nd, even though they were there. In fact, all supersonic cracks and muzzles were recorded on this one when you view them with the sonic visualizer, but probably only shots 1, 5, and 6 produced any reasonable and audible sound. Alright, so we've covered location, we've covered the overall objective and processing here, and so then and there's some other things I do in this one. For example, on bar 7, I somehow indicated the arrival times for the 6th muzzle blast as coming from bar 7, 11, 5, 10, 4, 6, 12, and first in that order, with first being the last. That was the only one in which I made an attempt to do that. And then I recorded a few other things. But anyway, let's go down to the bottom of this Excel spreadsheet, which this is, like I said, an ongoing project. And I created a map of where the videos are that I'm interested in. And this is, borrowed from the Vegas shooting map project. And we see here that there are about 3 different groups of interesting videos. And let's see, I don't have my marking tool up. Let's bring the marking tool up. Alright, with the marking tool, and probably a little bit, I don't know. Let's do a, what color would I like this evening? Let's do a yellow. Okay, and the groupings as I see them, because I already have a good idea of where the bullets came from, because I've gone through the processing on this. That's not big enough. If we draw lines representing an approximate path on the bullets, we can draw one like this, and based upon that, then we have this group up here. We have the groups that are close to the line, which would be these, and then we have the ones below the line. The green dots indicates videos which I have not yet included in the Excel spreadsheet, but need to. The red ones indicate the videos that I have at least made one pass on, entered it into the Excel spreadsheet, and have kind of located it on the map. So, 3 groups: above the line, below the line, and somewhat along the line. Now, given that the supersonic crack is generated on both sides of the bullet path in equal proportions, then videos which are, when a bullet comes along, videos which are above the line and below the line by the same distance, and distance here is this 3D spherical distance, not just, the simple XY distance from the path to the recording, then recordings at the stage video, if that were equal distance to bar 5 from the bullet path, they should show approximately equal lags. And so that's an important concept when looking at the numbers, because I calculate the lags for every possible video in here where I have signal. So let's go ahead and jump right to that result. And of course I gotta make sure this thing sticks on pointer. There we go. So I think this is the first one here we'll look at. So in this case I've created another spreadsheet that records the times in each video that the sonic shot called F1 for the first shot and the muzzle blast called M1 for the first shot. And I do that for each shot, so you can see we have shot 1, shot 2, shot 3, shot 4, shot 5, shot 6. And there's a sonic crack and a muzzle recorded for nearly every video. And there's, as you can see over here, 12 videos, or we'll see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 at the moment. This first column is a little different, and I'll explain that later. But anyway, so these are where in the video that event is located. So if you were to pull up the tall ace of spades, which I have a mnemonic for it called 1ST or first, then you could go to location 3 minutes 17 seconds and 543 milliseconds and find the signal for the muzzle blast for shot 2. And the only ones I could not eke out signals, and some of them were a little difficult, were for bar 4 for shots 4 and bar 10 for shot 4. So there's something going on with shot 4 that warrants some investigation that I've yet to do. In fact, there's a lot I need to do on this. But with these timings, I can then make estimates of the arrival times by noting that for all muzzle blasts, if the shooter is static, the recording location is static, and there's not great temperature difference or windage between the two, then for all bullets fired from the same position, you should have the exact same timing on each recording. And furthermore, the time between the shots will be preserved on all videos, provided the video is not moving. What that means then basically is if I massage these into global real time and I align one muzzle blast, so let's say I take M6, the muzzle for the 6th shot, and I calculate the global time of arrival, and then I align them all to be the point at which they agree. Then if the shooting position and the recording stayed stable, all the other muzzle blasts should line up within the tolerance of the measurement, the tolerance of the camera, and the movement. So if I do that for this one, and let's see, this is one where I did it for the first shot, but I want to go over to one that I aligned with the 6th shot, which is this one. So in this case, as you see over here on the column for the 6th muzzle blast, or the muzzle blast associated with the 6th shot, whoops, am I not on that one? It should have been all the same. I gotta look up here. No, I'm not. I'm on the wrong one. Here we go. So in this case, and I did all the combinations. Let's align the first one, align the second one, blah 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 blah, until I found, and I looked at them all. And I like either working from the last one or the first one, because that'll give the maximum error for the whole sequence, because it's the maximum time between them. But I haven't taken great care to make sure all these measurements are accurate down to sub-millisecond level. So right now they're on the order of 1, 2, or 3 millisecond in error, or what the margin of error, and some of them may still be questionable, and I have to go back and review it. So we see this, that I have, first off, that I have measurements for everything but these two. They're empty, which means that for all 12 videos, for all the shots, I could record both a sonic crack and a muzzle. which means then I can calculate the time of arrival between the two, and that'll give me lag, and I can plot the lag and get a good idea of the direction from which the bullet was coming and an approximate idea of the location and elevation of the shooter. Approximate. It's a qualitative measurement, and I did that for other things, not for these. I actually did do it for all these, but I'll explain that in a second. So in this case, these are not first shots. These are locations that I selected throughout the venue, which I have explained before, that give me a good idea on a large scale where the shooter was. And in this case, they're in the it indicates a location in the southwest corner at the Mandalay Bay or nearby at an elevated position, because the curved nature of this indicates the elevated position. Now, all of the first shot videos are in this region here, which would be yellow or red. And if the first shots are consistent with the yellow or red, then we're going to see lags 0.32 and greater. So that's the first thing we want to keep in mind. And if I were to plot some of those lags, then I should come up with a chart that is a sub piece of this. Now, because the lags only have 12 measurements per shot, that's a limited number of shots, and it doesn't create this nice big beautiful graph. It only pardon me, only creates a piece in there, so it's less accurate than this one. Alright, so here we are with this spreadsheet, and we line up muzzle blast 6, and according to my theories and projections that the shooter was in one static position, plus or minus 10 feet, let's say, or even 20 feet, then all the muzzle blasts should line up. So let's see how well they do. And what I've done is here, I've in this column down here, went ahead and had Excel calculate the average of all the muzzles for that shot. So obviously for shot 6, they all agree because I made them that way. And then in this case, the muzzle blasts for the 5th shot all add up to an average of occurring at 5 minutes 33 seconds and 0.699 milliseconds. So the difference for this one, which would become from bar 12, is 1 milliseconds difference. That's great difference. I mean, that's as best that I could hope for. In this case, we've got 4 milliseconds. 1, 1, 2, 5, 5, 3. Now this one's a little bit large. That's 11 milliseconds off. 2, 2, and 1. So these numbers all agree, with that one exception, to within the accuracy of my measurements, which means that 1, the shooter was not changing position significantly. 2, all the recordings were not changing position significantly. 3, that the temperature and wind between the shooter and the recording locations, all 12 of them, was not changing substantially. So that starts to give you a pretty good idea of what this can tell you. Now I can take all these numbers and refine them more and do fairly precise calculations, but I can't get exact location from them because my error for the locations, i.e., the longitude and latitude and elevation, suck. And I'll find some way in the long term to address that, but it just sucks. So anyway, let's go ahead and make sure that we can, in fact, that all these muzzle blasts line up. So 6 did by definition, 5 did within reasonable numbers. So here we have 0.32 seconds and 0.908 milliseconds, off by 1, blah, blah, blah. All these, I go up there, and again, it's TON. That seems to have a problem. All these except the Tonelli recording match within the margin of error that I would expect. Now, some of these numbers mismatching could be the fact that the recording location moved, or the shooter moved by a few feet. But as far as I'm concerned, plus or minus 10 or 20 feet is the same exact position. So 4 looks good. So that gives you high confidence that the rest of them are going to look good. So in this case we got 09, so that's off by 1, off by 1, exact, exact, off by 1, off by 3, off by 4, exact. And once again, the Tonelli is off by a little bit. So there's something different about the Tonelli that I need to go back and look at and reevaluate. So here, the muzzle blast for all shot, the third shot, all muzzle blasts occur at the same time when you align the sixth one. Now, in reality, all these muzzle blasts arrive at different times. And I'll talk about that in a couple moments. So anyway, we've verified that 3, 4, and 5, and 6 all agree. Let's go to 2. So we got an average of 8, 2, 9. Okay. So that's exact. That's off by a couple, off by 1. Exact, exact, 2. This one's off by 7. Okay. 1. And then again, Tonelli is off by too much. 1, 1. Okay, so with the exception of Tonelli and maybe a slight movement in one of the others, the muzzle blast for shot 2 agrees. That only leaves one more. So we got 0.163. So here we see that we have, well, that's 6 milliseconds. That's 3. That's 4. That's exact. That's 5, 2, 7. That's 9. That's a little large. Tonelli, yeah, again, Tonelli has a problem. 7 milliseconds. Okay, 155. Let's see. That's starting to approach. Well, anyway, all these are within my expectations. So with my expectations, having done this quite a bit, all the muzzle blasts align precisely. So now I have 72 data points times 2, because let's see, there's 6 by 12 is 72 minus 2, 70. So there's 70 data points here, and 70 for the sonics and 70 for the muzzles for 140. All of them agree with regards to the muzzle blast, and that's a pretty confident statement I can make now with those. And I would expect that as I add more videos and add to this spreadsheet, that it's going to come up with the same answer. So what do the other columns mean? Now let's go look at the supersonic cracks. What about supersonic cracks? They do not preserve the timing of the rounds, because the generation of the supersonic crack is dependent upon the longitude and latitude, or more specifically the downrange distance and the miss distance to the bullet path, and the bullet path changes for each round. Therefore, the arrival time of the supersonic crack is going to change. And if we start looking at them, we see that it does. I didn't average them out because it makes no sense to average them out, because they are not expected to be the same. And we see that they do change. Okay, so if someone comes along to you and says that, hey, I can hear that sound, the supersonic crack, and then I can line it up with another video and I can prove something, the only thing they're proving is that they don't know what they're doing. Now, that's not to say that that technique is absolutely wrong, because it's not, because these numbers can only vary at a maximum by upwards for this setting, for this location, for the speeds of the bullets that we're occurring, less than 1 second. So they're going to be within 1 second. But that's not good enough resolution to make any proclamation or declaration about much of anything, unless the arrival time is hundreds of seconds, because you want to get down into the 1 to 10% range before you make a declaration about anything. Alright, now if we take all this stuff and we've aligned it, obviously, and I'm not going to tell you how I aligned it because that's a long, complicated process, but if we plot them by alignment times, then well, actually, let's take a step. Well, let's go ahead. Let's see, I think I would have to align them, and that's where this column over here comes in. What I did was I selected a common region that is on all the videos related to a sound that's common to them all, and I aligned them to that sound. And when I did, let's see, Here we go. That's what this one is about. And you can see on this column that I aligned it all on the columns, which means that the times over here would be the actual arrival time that it occurred, including, the difference in delay. And I start looking at this and I realize that these aren't consistent enough because that number isn't accurate enough. So I have to go back and I have to be very, very careful on this and make sure I did it right. But once I do get it right, then I should be able to look up here and say, oh, relative to wherever that sound was coming from, I can tell you that, well, let's just take one example, but this isn't necessarily correct. So in this case, this event AS2 occurred in the middle of the whole series of volleys. So in this case, we found an arrival time of, well, let's take M1. Let's take the muzzles since we know that they're easier to deal with. So we got 5 minutes, 26 seconds, and 954 for that one. This one occurred after the previous one. Again, they should all, increasing. So up and down will be the interesting thing. And we'll see that the smallest number here is 26.954. Yeah. Okay, so this 26.594 is bar 5 occurred first. That is relative to whatever that AS2 sound is. The muzzle blast from the shooter's location arrived first. Now let's see who arrived last. So that would be the largest number. So let's see, largest is 27.11155, 155 for first, 189. So that would be bar 11 and bar 12. No, bar 11. So this is the one that had it last. Now this is where I start to question the number, and that's why I think that this is a little inaccurate, because the first, as far as I know, is the furthest distance from the shooter. So anyway, that needs more work. Now, let's go back and forget times of arrival, but let's look at the gaps. And I want to go back to one of the other ones here. Go back to the one where I aligned the 6th muzzle blast. And I go to this other tab or page, and I look at the difference in time between the sonic and the muzzle. Actually, I look at the time between a lot of things here, but the one I'm interested in is the one that's recorded in the muzzle, because this records the time of arrival difference between the muzzle and the sonic. And so that is the lag number. That's a number which gives you an idea of the speed of the bullet, the location of the shooter, the location of the recording, and a couple other factors. And so we can see, and I said earlier that it should occur greater than 0.32 and probably less than 0.56 or something. So let's verify that. Okay, so here we see what's the largest one we see. In this case, about a half. About a half. Here's one up there, 502. That's probably the largest one. Okay, so we verified the largest one. Now what's the smallest one that we see? Here's a 0.331. Oh, that's actually 0.515 right there. And here's a 0.273, which I believe to be the smallest. So we're pretty darn close. As measurements for lag goes, that's real close in terms of predictive capability of the lag plot map. So, but the conclusion from this would be that the lags produced by the first 6 shots in that evening are consistent with the overall lags of all the other volleys, and therefore we can start to conclude that the first six shots were fired from the same location, plus or minus a few feet, as the volleys. And that ties a lot of stuff together. Okay, so where are we at on this? We haven't used up too much time. I've covered the results, and for those who like results first, I've probably satisfied a few needs. I've showed you that this is an ongoing project, that not everything is complete. Some numbers, still need refinement. Some videos still need adding. and I still need to fill in that Excel spreadsheet up here with all that information, so that someone else can take this and use it as a reference base. Let's go over and now switch over to Sonic Visualizer. And for those who aren't familiar with Sonic Visualizer or don't like working with complex tools or something, you can terminate the video now, and you've got the results from the research that tells you where I'm at and what the results are. So let's go over and look at this one says that the video bar 7 records what I think might be 3 hits on people. Okay, well, first off, I want to know where bar 7 is. And if I've done everything right, then I go down to this map and I look, and bar 7, where's bar 7? 6, 1, 5, 8. Come on. Where's bar 7? Oh, there we are. Bar 7 was on the east side of the vendors located behind the sound booth. Right there. Which, if that's true, I would imagine then, well, it could be either side of the vendors, but I would expect that if somebody got hit, the sound would not travel as far, but it's low frequency, so it could be either side. The timing on it gives you a radius of where the sound might have come from, and I'd have to go through and calculate some real numbers in terms of the sound and the sound pressure level or the intensity of the sound to make any real statement of that. But bar 7, okay, so now I've got an idea where bar 7 is, and I can go and I can pull up that audio or video into Sonic Visualizer. I don't think I have it preloaded. No, I don't. Okay. So we pop over here into one of my favorite tools. Let's take a momentary break from the Sonic Analyzer, and I'm going to promote 2 products here. And this is for your benefit. If you don't know about the tool called Everything for searching your drive, then you're missing out on one of the most wonderful tools that you can have on your machine. It's specifically designed for Windows NTFS file systems, and it can search the names and all the attributes of a file, a million of them in a minute. And for NTFS systems, it is the fastest tool out there. And the end result is that if I don't know where something is on my system, I simply open up this tool, because it has, by default, it lists every file on your system, and I search for a Sonic Visualizer file. You can see all the Sonic Visualizer sessions, and in this case I was looking for, I wish my memory was better, bar 7, thank you. And I go bar 7, and there it is at the top. And that's the Windows link to it, which is located in my recent directory. And here's the actual session. So if I open up that session, so anyway, look at it and get it, because it's a good tool. Doesn't take up a lot of memory. It does indexing about, I don't know, 5 to 10 times faster than Microsoft Windows Indexer. So here we have a Sonic Visualizer session for that audio, and we can see that over here we have the first shot, and then we can see these are the cracks: 2, 3, 4, 5, 6. Okay, so the fourth one was kind of weak. It just created a disturbance in the force, as I call it. I changed the waveforms up there a little bit. So we got 5 strong supersonic cracks in this one, with the second one being a little weaker than the third one. And we've got, well, we know that we have muzzle blasts in there, and I've recorded them already, but what I came here for was to look at the energy associated with those 3 hits to, where was I? Over here. And I said that on bar 7, it was on the second one, the 5th one, and 6th one. Although it bothers me that that's out of place. Oh well, let's just see what the did I load up bar 7 or bar 5? Bar 7, okay. Second, fifth, and sixth. Okay, that means I'm still with it. And so we can start looking at these and zooming in. And we see that unlike most of the other ones, there's this big energy blob down there near the bottom end. And if I were to... Oh, and in this case, it's really already prepared to do this for me. I've got the window size set to 2048 for the power and 4K, which is a huge window size. So I'm going to get an accurate reading on frequency if I measure it. So the frequency center is down near 57 hertz. And the fact that it's that low, i.e. below the 60 hertz for a power line, indicates that this is a large, soft, resonant body of some kind. Now, if I set this back to a window size of 512 so I can see more precisely where it occurred, when it occurred rather. Okay, then bring down the gain, and you can see for this shot, which is 2, the width of that at this window size is about the same size as the sixth one, much smaller than the fifth one. So off the top of my head, the closest hit to that soft body, whatever it was, could have been a person, could have been a watermelon, could have been a jug full of water. I don't know the difference from the frequency signature yet. Then this would be the closest one. So shot 5 hit something. Well, wait a minute now. I'm going to think this through. Okay, normally the hits occur very close to the supersonic crack, but in this case it doesn't, so I'm going to reserve judgment on that a little bit. But it is a super huge signal. So let's just work with shot 2 and shot 6, which have just about equal energies. Okay, so let's go look them a little closer. Let's pull up the waveform for each one. Okay, we want to do the mean of the waveform here. Put it into, I don't know. Well, white, I guess, is good enough. Same with this down there. Oh, we don't need it there. Okay, so let's go look at shot 6. And I'm getting way down into here so you can see the actual signature of theoretically what I'm calling a hit. And I'll be verifying those later with much more research. Now this occurred at or near the supersonic crack, and if I increase that so we can get a better idea with the signal, then what we can see is the supersonic crack occurs right where that thin upper line is. Let me mark it so you can see it more clearly. So right here, just to the right of that line, I didn't want to go over the top of it, but there's the actual peak of it, and there's the actual trough of it. But that line is a supersonic crack. And then this thing, this big, long thing, is the result of a bullet hitting something and offloading its energy, and that offloading of energy into something causes the something to ring or resonate, as we call it, and this is the natural resonant frequency of that in response to a bullet hitting it. And that's one of the primary ways of recognizing a hit or a offloading of energy to something. So now if we go over to shot 1, we should see the same thing. So if I had my, alright, that was shot 5. I think I was talking different numbers earlier. Oh, there's 6. Okay, didn't shot 1 in it? Oh yeah. Okay, so we got 3 small ones and 1 big one. So let's go to shot 6, and when we expand on it, we should see something very similar. And once again, You know, we see that long. It's a little bit different this time. And of course I'm blotting it out big. I should have gone with a little. Let's do that again. And if I'm mumbling, you know, somebody in the comments can tell me, because people claim I mumble sometimes. But anyway, so here we go. The center of that is a large sinusoidal exponentially decaying signal, and the supersonic crack portion is there. Okay, so the large decaying signal occurs immediately after the supersonic crack. Now, the supersonic crack is a sound that arrives somewhere, and the bullet precedes it. So, I guess the question is then, is this part of the offloading of energy? I honestly don't know. It could very well be. Let's see what the other ones look like. Okay, that was 6. Let's go over to 1. Okay, I said that 1, there was a hit 2. There was a, oh, that's 2. 1. No, I did not record a hit for, at least I didn't mark it. I can sometimes get a little confused. Go back over to my chart. Nope, just 2, 5, and 6. Okay. And now I know you're probably all screaming, no, just 2, 5, and 6. You know, these things all run together after a while. Okay, so 2, 5, and 6. 2 is wider. That's correct. So we did 6. Let's look at 5 and see if there's a little bit of energy that precedes the supersonic crack. And again, there is a little bit, but not a lot. This portion right here is what we're talking. Then let's take a look at that big one, which might be a hit, but it doesn't occur with the supersonic crack. It occurs sometimes after the supersonic crack for 4. So I'm a little suspicious of that. So if we open it up and look at the waveform, and no, I don't think that's a hit. I think that that's something else, because the signal doesn't decay enough, and it also starts off oops. Okay. You see, it just starts off and it's approximately the same size all the way, although it tends to go out there. Okay, I'm going to reserve judgment on that one, and I'll have to let you know what it is. But it's not similar enough to the other hits to be an absolute qualified hit. But certainly 2 and 6 are hits that are fairly close by. I just, you know, I kind of want to reserve judgment. That looks like a bigger hit, but it doesn't have that telltale, I don't know, decay on it that I would expect. Maybe it's so big that these first 2 pieces are identical as far as the recorder is concerned. That would be the only explanation at the moment, and I am kind of guessing at that point. Alright, so I showed you what a hit might look like. The other thing that I want to show you is that in this case, the diagram of mine said I had recorded on this for bar 7. I had recorded supersonic cracks for 1, 2, 4, 5, and 6, but not for, let's see, what didn't I record here? I didn't record any supersonic crack for 3 and 4, so let's verify that, since we've got bar 7 up here right now. Okay, supersonic cracks are the big upper spikes that go up and down. And I'm, taking my time here to look at this, so I can see easily this one, that one, which are 6, 5, and I don't know. It looks like I can get 2, 3. So what did the chart say? And we know we have 1 already, 2, 3. So missing 3 and 4, it says. It's been a long time since I looked at these. So 6, 5, 4. Oh, it's there, but it's so weak as to be ambiguous. Right. Right here, there's a little mark. That would be 4. The supersonic crack for 4, but it's so weak that I need to do a little bit better look at it. Here's 2, with some kind of disturbance probably caused by the music ahead of it. And there's a really weak thing in there, which I probably at the time that I did the analysis of this said, oh, that looks more like an echo. So, and then I labeled F3 maybe as coming in there. So yeah, I couldn't quite determine which was which, so I just left it as unknown. That's what I did. Or actually what I did was actually just marked one area. So in this case, I marked this area here, which is probably off by the distance between those two, because all other well, anyway, too many weeds. That would be getting way down into the details. I wanted to kind of stay overview level tonight, and this is as deep as I'm going to go. So let's see if I've accomplished all my objectives tonight. Oh yeah, I'd like to also, once again give a shout out to the Vegas shooting map and Las Vegas shooting archive for the fact that they have those videos there that I can go grab them and analyze them without having to search all over the internet for them. Now I have copies on my machine now, but nevertheless it's an invaluable service, and that shooting map I access every day. Show picture, show notes, preload, 1 far, preload. I haven't done bar 5 yet, but we did bar 7, that's enough. Explore fruit salad, yeah. Oh, here's something I haven't done. Okay, so I have 2 things left to do. 3 things. Okay, maybe 4 things. All right, so let's go over to, in this case, I've got 2 videos which I've preloaded. This is the first shot, it's the Atollies of Spades video up there. And the second one is from that's bar 5, which the real name of it is Las Vegas shooting Aldine, any old bar stool, and first 2 volleys. So, and I think it actually only records the first volley. But so what I did here was on the top part, you'll see that I used on my spectrogram a different coloring. Normally I use the sunset coloring like here, but in this case I chose to use a more high contrast, more color, and back that up a minute. On this power one up here I used green. I normally use green like that, which gives a real clear indication of it's thinking about something here. Okay, well, I guess that wraps that sonic visualizer thing up for the moment. We can go restart it. For some reason it wants to die. I probably used too many of them open, so let's go ahead and close the other ones. They'll probably die out too. Nope. Sometimes my poor old computer just gets a little overloaded. Wait a minute here now. Yeah, that one's not adequate. Okay, and let's see if I can pick that session back up. Probably should close those out. Let's go look at my memory. Yeah, okay. It's not tonight. It's I think it's this one. Aldine bar 10, no. Laying down, no. Taxi versus under, no. Where the heck did I store that? Now I have to wait for it to compute all the values. Oh, I got lucky. Okay. Or did I? It's going to take a couple minutes for it to figure out what I've got on the bottom scale here. But up here on the top on the power spectrogram, you see that I used the fruit salad coloring. And sometimes with the fruit salad coloring, I can see things that I can't with the green one. It just looks different. So in this case, and this is the log frequency spectrogram using fruit salad also. So for example, if I turn down the intensity on the fruit salad and expand out the time scale, then as I adjust it, I can start to make a distinction between these types of spikes real quickly and this type of spike, because these types of spikes, which are gunshots, have a thinner red component to them. So in this case, it's shot 6 sonic, 5 sonic, 4 sonic, 3 and 2. And then if I went over here to the left, there should be 1, which is also red. Okay. So in that way, I can use the fruit salad coloring to quickly separate out and distinguish between, in this case, drums and cymbals and gunshots. Now you say, well, you could just have looked up there. They're a little bit taller, but that's not always the case. So if I were to flip back over to, well, it's just green. So we can use this top one up there. You can see that this one is a little bit clearer. I can't compare them directly because that's the first shots, which only has 3 good supersonic cracks in it. But let's align them up. And remember, I said you can't really align supersonic cracks, but let's line them up anyway. And you see they line up, like I said, on the gross scale. But when you get way down into the weeds, it becomes almost impossible to line them up, because unless you're at the shooter, the recorder, and the bullets are all at the same spot, then they make different lags. Okay. So anyway, I wanted to show you how the fruit salad color, which actually applies different amplifications to different frequency bands, can be useful. And that would be it for that. Alright, so covered that. Yeah. Talk about YouTube problems. Oh yeah, I'm a little concerned about that. You made this video for child and you're legally required to do something, to tell us about it. That's weird. Yeah. What I was going to say here is that if you look close up, you can see that gunshots are constrained to a smaller time frame than the bass drums or the cymbals, but yet they're both what we call percussive sounds, because they tend to go up and down. And that's one of the key differences between gunshots and a lot of other percussive sounds. So for example, up here you can see that there's this signal going up and down, which is fairly thin, but it also is kind of wide too. And so you can, with the color map from the fruit salad on the power spectrogram, quickly, well, let's just go apply a color fruit salad. And as you can see, there's a dozen different colorings. Oh, so in that case I was going to be wrong. That is a gunshot related sound. Yeah, I need to bring it down a little bit to make a real distinction, but all those preserve the... Now that's all... No, I don't think that's a gunshot sound. It's just that in this case, on the first shots, the distinction between a gunshot and some of the music sounds is not quite as distinct as it was down here in the bar 5. So in this case, you can see... there we go. So in this case, as we adjust it, we can see that these loud sounds from the music, while similar in nature to the gunshot, the gunshots have both a louder, more intense one, a little bit narrower, and yet I had to go to quite a different amplification there to bring out that difference, because down here they start to look real similar. If I lower it further, then once again you can see that there's a distinction here. That's probably a reflection from that supersonic crack. Again, there's some reflections going on there, reflections there. Here's a muzzle blast. That looks like a muzzle blast type thing. So playing with the amplitude gain and contrast and color band gain is an important aspect of using Sonic Visualizer. And in this case, the narrower the pulse, the more likely it is to be a gunshot. The wider the pulse, the less likely it is to be a gunshot. And once again, remember that the width of the pulse for muzzle blast are about 3 times larger than the width of the pulse for the supersonic crack, but they all suffer from the innate and poor frequency response of both the recorder and the air. That is, these little cracks and explosions from the muzzle or the bullet both occur at a frequency that's much higher than either the air or the recorder can deal with. And so in many ways, the things that we see here really are distortions of the real events, even from a sound perspective. Alright, that's enough. We're getting too far into the weeds. So we'll catch you in the next one. I gave you a pretty good overview of what I know about the first shots. Once again, I'll repeat it. The first shots are very similar to all the volleys. They come from one shooting location. The shooter didn't change his position much for them. And that position is consistent with a position which is southwest of the venue at an elevated position close to the Mandalay Bay. All right. Thank you for listening, and we'll see you in the next one.